Om Sri Sai Ram. We are beginning the calculus part with the chapter called Continuity and Differentiability. And in today's class, we will be discussing about continuity of a function. When we can say that the function is continuous at a given point, when we can say that a function is continuous in a given interval, how to prove at a given point function is continuous or discontinuous, we will be discussing these things. Basically, what do you mean by continuity? Now, let us say you are traveling from Bangalore to Patna. So, there are trains which will directly take you to destination. We call it direct train. And you get into the train and finally you reach Patna. But suppose you don't get reservation in that train, the next alternative is in between you change trains. For example, from Bangalore you go to Calcutta. From Calcutta you take one more train to reach Patna. So in this way we say that the journey became discontinuous at a point. It was not continuous journey. You got down at Calcutta, waited for next train, and then you got into another train and reached. In the same manner, whenever a function is given, if you draw the graph of the function within the given intervals in such a way that while drawing the graph, if you don't need to lift the pencil from beginning till the end, we say that the function is continuous. Whereas, if you have to lift the pencil in between and then draw the remaining part of the curve, we say it is discontinuous. Small examples are given in the textbook. We will discuss those two examples. We have drawn the graphs of that and then we go to the actual definition of continuity. Let us look at the first example. Fx equal to 1 if x is less than or equal to 0. Means what? Any value if you give less than 0, let us say -1, -2, -3, -4, for all of them the value of x is, this is, let us say this is 1 and let us say this is 2. Y value is 1. For all the values -1, -2, etc., the y value is 1. Then it says if it is greater than 0, if you take values greater than 0, let us say +1, +2, +3, etc., it is 2. Remember, 1 and 2 are constants. These functions are called constant functions. And we find that the given function fx is changing from 0. At 0 it is changing. Look at the second example. This is the graph for the second function. Fx is equal to 1 if x is not equal to 0. What do you mean by that? For any positive value or for any negative value, it is 1. But only at 0 it is 2. You can see the graph, it is more like a straight line. This particular graph is that of the function fx. What is this? Whether you take +1 or +2 or -1 or -2 or -3, the value of fx, value of y is 1. But at x equal to 0, it is 2. This graph also is discontinuous. Means up to 0, y value is 1. Beyond 0, its value is 1, but at x equal to 0, it is 2. This is another example of discontinuous function. In a simple terms, if you have to understand, if you are able to draw the graph, let us take one more example. Let us say this is the graph. Let us say this is the graph of a function. Let us say here it is x equal to a, and let us say here it is x equal to b. You can see that to draw a graph from x equal to a to x equal to b, we don't need to lift the pen. So we say it is continuous. In between, if you have to lift, now let us take one more example. So what do we find? At this particular point, up to this point it is continuous. After this we have to lift and then take it. So we say that the graph is discontinuous, and graph is that of a function, so function is discontinuous. So this is one way of finding out whether the function is continuous or discontinuous. What is the way? By drawing the graph. But every time it is not very easy to draw the graphs. So we have an algebraic method. And what we are going to learn today is algebraically, without drawing the graph, how we can find out whether the function is continuous or discontinuous. So let us go to the first definition of the function. The first definition says, suppose if f is a real function. What do you mean by real function? We have learned what are real numbers. If the domain of the function is from set of real numbers and range of the function is also real numbers, it is called real function. When domain and range of a function is that of real numbers, the function is called real function. So he says, suppose f is a real function on a subset of real numbers. It is taken from real numbers only, and let C be any point in the domain of f, then f is continuous at C. When it will be continuous? When it will be continuous? When limit of the function, limit x tending to C, f of x is equal to fc. So this is the first definition. What is the first definition? Suppose f is a real function on subset of real numbers, and let C be any point in the domain. The domain can be, let us see, of positive numbers, it can be of negative numbers, it can be of rational numbers. Any number if you take in that domain, at that particular point, limit of the function should be equal to value of the function. What do you mean by value of the function? It is very simple. In a given function, in place of x, substitute that value, you get value of the function. And what is limit of the function? We are going to learn. How to find limit of the function? We are going to learn. But when both are equal, we say the function is continuous. The same definition we elaborate little bit more, and we come to the second definition. What does the second definition says? A function is continuous at x equal to c if function is defined at x equal to c, the value of the function at x equal to c equals to limit of the function. In other terms, limit must exist. At the given point x equal to c, two conditions. First condition is limit exists. Second is limit of the function is equal to value of the function. First, let us understand what do you mean by limit exists at a given point x equal to c. What does it mean? It actually means that the left hand limit is equal to right hand limit. What do you mean by left hand limit? Let us say we are testing the continuity of a function at x equal to c. Let us say c is 5. Take a value little less than 5. Let us say 4.99. At 4.99, whatever is the value of the limit, if it is equal to right hand limit, what do you mean by right hand limit? A value little more than 5, let us say 5.001. At 4.999, whatever is the value of, whatever is the limit, if it is equal to at 5.001, we say the left hand limit is equal to right hand limit and limit exists. So how do you prove limit exists? For the first one, the left hand limit should be equal to right hand limit. How do you write left hand limit? We write limit x tending to c minus h f of x is equal to limit x tending to c plus h f of x. Remember, This h is a very small number, 0.0001, something like that, very small, but it makes difference. It is something like, let us say somebody has given you 100 rupees and in exchange you have given him the change for 99 rupees 99 naya paisa or 9,999 paisa. Actually we take both of them as same, but both are not exactly same. So that's what, to that close is the value. So this h is almost 0, almost tending to 0, but not 0, little less than 0. So if you subtract that, you get left hand limit. If you add that, you get right hand limit. If both of them are equal, the first condition satisfies. What is the first condition? Limit exists at that point. Second condition, whatever limit exists, that is called limit of the function. And that limit of the function should be equal to value of the function. How do you get value of the function? Now let us say you have got a function fx equal to x square minus 5 is a function. How do you get value of a function? Let us say at x equal to 3 we want to know. Simply substitute 3 in place of x, you get 3 square minus 5 equal to 4. This is called value of the function. Then what is limit of the function? Limit of the function is limit x tending to 3 f of x. This is called limit of the function, and then this is called value of the function. Both should be equal. Now let us try defining it in a different way. We have learnt when it will be continuous. Now we should be able to tell when they will be discontinuous. At a given point, when we can say a particular function is discontinuous, if any of the conditions or both the conditions are not satisfied. In other terms, when left hand limit is not equal to right hand limit, we say function is discontinuous. Or let us say limit exists, left hand limit is equal to right hand limit, but it is not equal to value of the function. Then also we say that x equal to c is a point of discontinuity. So in this particular chapter or in this particular lesson, we come across 3 types of problems. We will be doing 2 or 3 problems of each type in order to understand the concept, and in the process we also learn how to solve the problems. What are the 3 types of problems? First is very simple. He will give some function and he will ask you to find out at a given point function is continuous or not. Second kind of function, he will give a function to you, or he may also give values. He may say find out at a given values the function is continuous or not. The third kind of function, he will say it is continuous. There will be some unknowns whose values you have to find out. So basically we come across 3 types of problems. Let us begin with very simple first type of problems. We will go to the problem number 1. This also happens to be the first problem of the textbook. First problem of the exercise. What is the problem? Function is 5x minus 3. He is asking prove that this function is continuous at 0, it is continuous at minus 3 and also at 5. X equal to 0, x equal to 3 and x equal to, minus 3 and x equal to 5. But before we go to solve the problems, some facts which we should know. What are the facts? Polynomial functions, identity functions, constant functions, they are always continuous. We don't need to even verify. You can straight away write that if it is a polynomial function, it is going to be continuous. If it is a constant function, it is going to be continuous. We also need to know little bit of algebra of functions. What is algebra of functions? Suppose you have got two functions. One is f of x, another is g of x. Let us assume that both are continuous. If both are continuous, their sum also will be continuous. That is, if fx is continuous in a given interval at a given point, gx is also continuous in a given interval at a given point. If you club both of them, fx plus gx is going to be continuous. Their difference is going to be continuous. Their product is going to be continuous. Their quotient is also going to be continuous. Means what? What is that we are trying to tell? F plus g, f minus g, f into g and f by g. F and g are independently continuous functions. So their sum, their difference, their product, their quotient are also continuous, with one small condition here, that the denominator g should not be a constant function 0. It should not be 0. In all other situations, these functions are continuous. This is called algebra of functions. Here and there we will be using it as and when we come across situations. So now let us come to this particular problem. In fact, without solving only you can tell off. What we can tell? Since the given function 5x minus 3 is a polynomial function, it is continuous. So it will be continuous at 0, it will be continuous at minus 3, it will be continuous at 5. But since he has asked as a problem, we can also show it. How do you show it? Find out limit of the function, find out value of the function. If both are equal, we say it is continuous. How do you find limit of the function? We want, let us say we want to check at x equal to 0. We want to check at x equal to 0. So how do you do? Limit x tending to 0 fx. What is it? Limit x tending to 0. What is the function? Write the function. Function is 5x minus 3. And then proceed to the limits. X is 0, you get 5 minus 3 equal to 2. Now find out f of 0. How do you find f of 0? In the given function, substitute 0 in place of x. You get 5 into 0 minus 3. Sorry. Here when we substitute x tending to 0, you get 0. 5 into 0, 0. Minus 3. Answer is minus 3. Similarly here also you get minus 3. So what do we find? We find that limit of the function is equal to value of the function. So we say the function is continuous. In the same manner, you can test for minus 3, you can also test for minus 5. What is that you need to change? X is tending to, instead of 0, you will say x is tending to minus 3. Instead of minus 3, you will write x equal to 5 and then solve. A very, very simple problem. Let us move to the next problem. Second problem. This happens to be the third problem, B bit in the textbook. What is it? He says fx is equal to 1 upon x minus 5. What is the question? He is asking, examine whether this function is continuous. He has not given any interval. He has not given any value. So how do you test? You can test at any point, any real number. And even without testing, with the help of a statement, you can say it is continuous. How? How it is continuous? You can see that the given function is a rational function. What do you mean by rational function? Where numerator is a polynomial, denominator is also a polynomial. You are familiar with x minus 5. So there is no difficulty to understand that the denominator is a polynomial. How do you say numerator is a polynomial function? Numerator is also a polynomial function because it is a constant function. Every constant can be written as, for example, 1 can be written as 1 into x to the power 0. So that also happens to be a polynomial function. Polynomial function divided by polynomial function. We have studied in algebra of continuity. if both numerator and denominator, means if f is a function, g is a function, f by g is also continuous when f and g are continuous. So, this being a constant function is continuous, this being a polynomial function is continuous. Continuous function divided by another continuous function is continuous. You can directly say that the given function is continuous because numerator being a constant function is always continuous. Denominator being a polynomial function is also continuous. So, the rational function is continuous. You do not even need to solve the problem and you can conclude this way. Let us move to the third problem. This happens to be the fifth problem. He is asking, is the function defined by, how does he define the function? Fx equal to x if x is less than or equal to 1 and it is 5 if x is greater than 1. He is asking, is the function defined, is continuous at x equal to 0, x equal to 1 and x equal to 2. He is asking at all these points whether the given function is continuous or not. Remember, all polynomial functions are continuous in a given interval. Look at the first one, fx is equal to x. Fx equal to x, and what is the interval? Less than or equal to 1. So, it is automatically going to be continuous. Why? Because it is a polynomial function. Similarly, fx is 5 when x is greater than 1. For any value greater than 1, it is 5. So, it is also continuous. So, what is it we can conclude from that? The first function being a polynomial function is continuous when x is less than or equal to 1. Look at the values which he has given. X equal to 0. 0 is less than 1. So, you do not need to test whether it is continuous at x equal to 0 or not, because 0 is within the domain of the first function in which it is continuous. Look at the third one. He says x equal to 2. For x is greater than 1, whatever value you take greater than 1, it is 5 only. So, it is also continuous. So, if at all there are any chances of discontinuity, it happens when the intervals are changed. Now, look at the given function and see where the intervals are changed. The intervals are changed at 1. So, we actually need to test the discontinuity or continuity at x equal to 1. At all other points, it is going to be continuous. But make it a point to mention it, because he has asked us a problem. So, we will say at x equal to 0, fx is continuous, and give the explanation as fx equal to x is a polynomial function. Since it is a polynomial function, in the given interval it is going to be continuous, you do not need to verify. Come to the third point, x equal to 2. At x equal to 2, also fx is continuous, as fx equal to 5 is a constant function. All constant functions are continuous. So, what is left? It is only x equal to 1, and let us check at x equal to 1 whether it is continuous or not. At x equal to 0 it is continuous, at x equal to 2 it is continuous. We are checking where x equal to 1. So, we basically need to test wherever the interval is changing. If the interval is not changing, more or less the functions are going to be continuous. So, let us check at x equal to 1. How do you check at x equal to 1? Two things we have to check. First, whether limit exists. How do you check whether limit exists? If the left hand limit is equal to right hand limit. So check what is left hand limit. Limit x tending to 1 minus h, f of x. If it is less than 1, what is the function? It is x. So it is limit x tending to 1 minus h, function is x. Proceed to the limits. Limit h tending to 0. What actually we need to do? In place of x, we have to write this 1 minus h. And then proceed to the limits h tending to 0, you get the answer 1. Same way, find out right hand limit. If it is more than 1, its value is 5. Function is 5. So if you proceed to the limits, you cannot substitute 1 plus h in place of 5 because 5 is a constant, it is 5. What do we find? We find left hand limit is 1, right hand limit is 5, they are not equal. Since they are not equal, function is discontinuous at x equal to 1. Since left hand limit is not equal to right hand limit at x equal to 1, so x equal to 1 is a point of discontinuity. So this is how we solve this problem. We will move on to the next problem. This happens to be the 7th problem of the exercise. He says find all points of discontinuity of f where f is defined as, how does he define fx? Fx is equal to modulus of x plus 3. Then it is minus 2x. Then it is 6x plus 2. The first one is when x is less than or equal to minus 3. Second one is greater than minus 3 but less than 3, and this is greater than or equal to 3. Like last problem, he is asking find all points of discontinuity. Since we have to find out all points of discontinuity, does it mean that we need to check it 1, 2, 0, 3, minus 1, minus 2, minus 4? No. Why we don't need to discuss? For a simple reason that, look at the functions. Modulus x plus 3, it is a modulus function. Just like polynomial function, modulus functions are also continuous. So since it is a modulus function, it is continuous. Where it is continuous? In the given interval less than or equal to minus 3. Look at the second one, minus 2x happens to be polynomial function. Again it is continuous between minus 3 and 3. Look at the third one, 6x plus 2 is also a polynomial function. So it is also going to be continuous in the given interval greater than or equal to 3. So where it may be discontinuous, it may be discontinuous only where the intervals are changing. Now the question is where the intervals are changing. Look at it. At minus 3 it is changing. At 3 it is changing. Apart from this minus 3 and plus 3, for any real number, given function is continuous. So let us check only at these 2 points. But before you check, you mention that the given function, given functions, not one because there are 3 different functions, are continuous in the given intervals. Why they are continuous? Mention as they are modulus and polynomial functions. So we don't need to check at any other point. We need to check only at the points where the interval is changing. So where the interval is changing, he says this is the function if it is less than minus 3. This is the function if it is greater than minus 3. So let us check at minus 3. Then check at 3. Come on. So at, or before you write this, you can also say, so we test the continuity at x equal to minus 3 and 3 as intervals are changing. Since intervals are changing, we are going to test. So let us take up first at x equal to minus 3. How do you test? Find out left hand limit. How do you find left hand limit? Limit x tending to minus 3 minus h fx. What is the function if it is less than minus 3? Function is this. So substitute limit x tending to minus 3 minus h. In place of fx, write the function modulus of x plus 3. Substitute in place of x this limit h tending to 0 modulus of minus 3 minus h plus 3. Proceed to the limits. If h tends to 0, you will be left with modulus of 3. What is modulus of any number? Is always a positive number. That's the speciality of modulus function. Modulus of minus 5 is 5. Modulus of 5 is also 5. So modulus of minus 3 is 3. And 3 plus 3, you get the answer 6. Find out right hand limit. What is the function if it is little more than minus 3? X is greater than minus 3. This is the function. Substitute limit h tending to 0. In place of x, you have to write this. Proceed to the limits h tending to 0, you get the answer minus 6. The first one has given you the answer, first one has given you the answer. Modulus of minus 3 was 3, 3 plus 3 is 6. Here it is minus 2 into 3 is minus 6. So what do we find? The left hand limit is not equal to right hand limit. So the function is discontinuous at x equal to minus 3. In the same manner, check whether it is continuous at 3. So fx is discontinuous at x equal to minus 3. Come to x equal to 3. So how do you take left hand limit equal to limit x tending to 3 minus h. If it is less than 3, the function is minus 2x. Proceed limit h tending to 0. In place of x, you write 3 minus h. So minus 2 into 3 minus h. And then proceed to the limits h tending to 0. You get the answer minus 6. Find out right hand limit. Limit x tending to 3 plus h. If it is more than 3, if the function is more than 3, the function is 6x plus 2. And then proceed to the limits h tending to 0. You get 6 3s are 18, 18 plus 2 equal to 20. Here also you find left hand limit is not equal to right hand limit. So, x equal to 3 is also point of discontinuity. Before we come to a conclusion, once you check whether we substituted right values, when x equal to 3, the left hand limit is little less than 3, 3 minus h. If it is little less than 3, the function should be taken as minus 2x. So, in place of x, we substitute 3 minus h. When you open the bracket, you get minus 6 because h becomes 0. Right hand limit 3 plus h, little more than 3. If it is little more than 3, it is 6x plus 2. In place of x, you write 3 plus h. When you substitute h equal to 0, 6 3 is 18 plus 2, 20. One is minus 6, another is 20. Both are not equal. So, we conclude that the function is discontinuous at that point. We also check at this particular point, once again x equal to minus 3. Minus 3 minus h. When it is little less than minus 3, the function is modulus of x plus 3. So, in place of modulus of x, we write minus 3 minus h plus 3. So, modulus of this, when we want to take, when we substitute x is 0, you get modulus of minus 3, which is 3. 3 plus 3 is 6. So, the value is correct. Right hand limit is minus 3 plus h, and in that case the function is minus 2x. Here is the mistake. You can see it is not 2x, the function is minus 2x. So, this is minus 2, and when you substitute, you get plus 6. So, both left hand limit and right hand limit are equal. Since they are equal, we say at x equal to minus 3, left hand limit is equal to right hand limit. So, the function continuous at x equal to minus 3. So, this is the correction which we have to do in the problem. We have not taken minus sign into consideration when we are taking the function. So, please make this correction, and you find that at x equal to minus 3 it is continuous. So, there is only one point of discontinuity, that is x equal to 3. So, that is the conclusion. We come to the last problem of this session. The problem goes like this, like the previous one. He says find all points of discontinuity, and the function is defined as x upon modulus of x. When if x is less than 0, and it is minus 1 if x is greater than or equal to 0. Look at the functions. Is again a rational function, polynomial function divided by a modulus function. We know that both are continuous. As a result, this is going to be continuous in the given interval less than 0. Second one being a constant function is also continuous. So, in the respective intervals they are continuous. We only need to check where the intervals are changing. Intervals are changing at 0. So, only at 0 we need to test. Rest all points we can say that it is going to be continuous. So, first write off the given function x upon modulus of x is continuous in given interval x less than 0 because it is a rational function of polynomial and modulus. Fx equal to minus 1 is also continuous in the interval greater than 0 being a constant function. We need to check at x equal to 0. So, check at x equal to 0, left hand limit is equal to limit x tending to 0 minus h fx, limit x tending to 0 minus h, substitute the function is x upon modulus of x. Proceed, limit h tending to 0. What we actually need to do is, in place of x you have to write this. So, 0 minus h by modulus of 0 minus h. 0 minus h, if you simplify further, it is limit h tending to 0, this is minus h and modulus of minus h is h. So, both will get cancelled, you get the answer minus 1. Come to the right hand limit, limit x tending to 0 plus h. If it is more than 0, he has already given that it is a constant function minus 1. So, what do we find? Left hand limit is equal to right hand limit. So, even at x equal to 0, it is continuous. What does it mean? There is no point of discontinuity. So, write this conclusion as left hand limit is equal to right hand limit. So, yes, we need to check one more thing which we have missed, the second condition. What is the second condition? We found the limit, find out the value of the function. What is the value of the function? f0. At x equal to 0, it is again minus 1. Since limit of the function is equal to value of the function, so it is continuous at x equal to 0. There is no point of discontinuity. With this, we come to a conclusion. What is most important thing to remember is, find out limit of the function. How do we find limit of the function? Find out left hand limit, find out right hand limit. If both are equal, we say limit exists. Also find out value of the function. If both are equal, we say it is continuous. We need to check only where the intervals are changing. In general, given functions are either polynomial functions or modulus functions, so they are always continuous. We will continue this exercise in the next session. Thank you. Sai Ram.